Hello and welcome to Section 4 of Learning Computer Vision with Python 3. In this section, we're going to go deeper into TensorFlow and see how we can build a general-purpose image classifier using the deep learning method within TensorFlow. This will be an extension of what we learned in the second session, where we learned how to classify human-written digits, but this is quite a bit more powerful, as this will work on natural general images of people, animals, food, everyday objects, and so forth. So to start, I want to talk a little bit about what TensorFlow does and talk a little bit about the general workflow of TensorFlow. So starting, what is a tensor? So this is the definition from Wikipedia. In mathematics, tensors are geometric objects that describe linear relations between geometric vectors, scalars, and other tensors. Given a reference basis of vectors, a tensor can be represented as an organized multi-dimensional array of numerical values. Now, however, according to Google, the makers of TensorFlow, a tensor is any multi-dimensional array. And these arrays can have any data type. So basically, according to Google, a tensor is basically anything that can be, computerized data. So they basically generalized the word so much that it doesn't really mean a whole lot. And I personally don't like that coming from engineering and physics background, but TensorFlow is so powerful and useful that I'm going to get over that. But I just like the audience to be aware of that, and if you're ever worried about misusing the word tensor, well, don't be worried about it, because Google completely misuses it anyway. But for now, all you need to know that within TensorFlow, a tensor is just some sort of data, usually a multi-dimensional array, but it could be basically anything. Images, text, whatever. With that in mind, TensorFlow is in general a high-performance numerical library. It is primarily geared towards machine learning, but that doesn't mean that it's exclusively made for machine learning. It can also be used for simulations and solving, complex partial differential equations and just about anything numerical. We're only concerned with machine learning and, in particular, deep learning in this course, so, we are going to be using it for its main purpose, but just be aware that it's generally used for constructing and analyzing complex numerical models. So before we go into, building a classifier, I just want to show a little bit about how you would generally use TensorFlow for, very basic usage. So, okay, we're going to get started as normal. We're going to change directories and make sure that we load, key libraries and make sure we can display images and so forth. So pylab inline and change to your directory. Of course, you're going to have to do that in order to load this Jupyter notebook right here, but just like to make sure that this is clean. We import TensorFlow. We use the standard convention. We're going to import TensorFlow as TF, because writing out TensorFlow every time is a little tedious. Strictly speaking, since we did pylab inline, we don't explicitly need to import NumPy like this, but it's good practice in general, and if you want to copy some of this stuff out to other scripts, you need to make sure that that's there. Alright, so we executed that, and let's start with a really, really simple TensorFlow example. So we're just going to do some really basic arithmetic. Actually, we don't need this line right here because we already imported it. So we're just going to define some constants within TensorFlow. We just do so like this. So a equals tf.constant2, and similar for b. Constants can be just scalars like this, or they could be vectors or matrices like this. Show you very basics. We're just going to create simple scalar constants, and we're just going to add them together. So when you do that, you can define your constants, or we're going to see placeholders momentarily. We define that, and then we create a TensorFlow session using the with clause. So, when it goes out of scope, once we're outside the with clause, then this will go out of scope and we'll close the TensorFlow session. This can be important depending on what resources you're using, like if you're using a GPU or so forth, you want to release that. But right now we're just going to be talking about this with the CPU. So we're just going to show what our constants are and then create our session, and then within our session, TensorFlow has operator overloading where it makes sense. So It understands what is meant by A plus B, where A is a TensorFlow constant and so is B. And, it has all the arithmetic operations like A times B, minus, division, power, so forth. It understands that. And we're going to do the same thing a second way where we create placeholder variables. So oftentimes you need to construct your model. That's what TensorFlow is based on. It's basically input-output models. So you have your input. It could be numbers, it could be images, it could be words or whatever. So you generally need to define placeholders before you input your data. And then you define a model here. And you construct your model here. We're just saying we're defining addition just as you would normally define it. This can generally be something more complex, like building, a neural network, a convolutional neural network, and so forth. We'll see just a little bit of that momentarily. But define your inputs, you define your model, you define your operations, and so forth, and you create what is called a graph. That's going to take your inputs and map it to the desired outputs. Then similarly, we're going to create a session, and then we're going to run our operations. In this case, we have to tell it what the values are. We're just saying 2 and 3. Run this right here. And then just does exactly what you expect. So not too exciting, but just so you understand, a little bit about what TensorFlow is doing. Because we're going to take advantage of some higher level libraries for this lesson. But this is important if you want to go further in the future. Similarly here, we're going to do matrix multiplication. Now, I mentioned that these constants can be more than just scalars. In this case, we're defining matrices. So a 2 by 2 matrix and a 2 by 1 matrix, so we'll get out a vector. Then we just tell it to matrix multiply, create our session, then run it, and then print the result. Execute this right here, and there's our result. So, again, very basic, but very important in the future. So, we're not going to define our full network in this lesson because that's very complex and very time-consuming to execute. But I'm just going to mention here, these are the general steps for creating your own convolutional neural network. You're going to create what is known as layers. So you define your input, and then you create a bunch of layers and stack them together and define how they're connected and find an output layer. And then you have to define some other things like how you're going to train and so forth and how you're going to evaluate. But again, this is just for your knowledge. Deep learning is, forgive the pun, a deep subject. Figuring out the architecture that's necessary and exactly how to train. That is beyond the scope of this course, although I would invite everybody to learn more about that. But here we're just going to see how we can utilize what's already done. But you can see here, if you do want to go further, this is how you would get started. Okay,